Hello, I'm going to in this video just talk about the Further Mechanics Maths 2019 OCR A paper. It was a relatively challenging paper, as in the first one of the series, as we can see from the grey boundaries, 52 out of 75 for an A star, down to 18 out of 75 for an A. For an E, sorry. So it was relatively challenging. These are the comments made by the examiners in general about how students responded and how the better students gain marks and whatever. What I'm going to do now is quickly kind of go through some of the questions. There will follow on this playlist more detail on some of the questions beyond question 2, which does the questions a little bit more in a kind of walkthrough format rather than just kind of commenting on the questions, if you like. So question 1 is a centers of mass question. So you're basically using, if you use a standard formula, things like x bar v is equal to the integral of all of the moments of the disk that you're doing. You use the formula like that. The first bit most people got right about symmetrical. Apparently the examiners say some people wrote uniformly distributed, which they did not accept because that would imply it was cylindrical or could be cylindrical, which it isn't. So they didn't accept uniformly distributed, but symmetrical about the x-axis. Right, now, I say we're just using standard formula here, volumes of revolution formula, and notice here we're just timesing x by y squared there, equating x bar times by the volume here. And then Bob's your uncle, you get to 2.62. The only thing I would say here, and it's quite important, and it is mentioned in the examiner's report, I've used the integration function on the calculator here. You are not, unless it's saying so that, or give detailed reasoning or whatever, they expect you to use the calculator. So you'd be wasting your time doing all that stuff of integrating that, and then putting the limits in. You'd be wasting your time. So use your calculator unless the wording of the question implies not, or if you have to get exact and the calculator doesn't give you exact, or it says so that, or whatever. But here the question said find the x coordinate of g. There's nothing in the question that implies write out the integral and work that out by hand. Okay, so use the integration function and save yourself the time. There's a lot of stuff later on in the paper where you have to where you really do need the time, so that's important. Right, second bit is a fairly standard thing about finding. You have to kind of draw a diagram, and I've marked in the lengths. I tend to prefer to draw the diagram as it is. You can use a diagram on the question paper, as I've done here, and draw in the vertical line at an angle. Don't attempt to tilt it to draw it, with the vertical line here and then draw that shape. It's going to be hard. So you can just draw in your vertical line and then make sure you're marking the appropriate angle that you're being asked for, and then marking the appropriate distance, and the answer is 68.3. So that's question 1. Question 2 is I don't think there were many issues with question 2, relatively standard question on dimensional analysis. So there you go. And apparently some people expressed the ratio incorrectly or got the wrong way around. It might be a good idea to write 1 to 1830 there as your ratio, but a few people messed up on that. And then a few didn't appreciate the subtlety with question C. It's only 1 mark. They often like to put in a bit of interpretation, modelling questions or whatever at the end. Dimensional analysis cannot be used to determine the dependence of little a on n. because little a, because n is a dimensionless quantity. Okay, question 3, as you'll see, is is the first one in the playlist after this, using equations of motion or equations of constant acceleration, SUVAT, some people call them, and then using some energy, and there's no specific things mentioned in a mark scheme on that. Let me just quickly look to see, not the mark scheme, the examiner's report. It did. Oh yeah, there was one comment. It because it did surprise me a little bit, where it insisted you use this equation. I might have used v is equal to u plus at in vector form and then substituted that in. But if it says use that equation, that means at some point you're going to have to use that equation, which I did here. Okay, so that's quite important. If it says use the equation, then you've got to use that equation. So that was one of the things that was commented on. So part B, some lost marks for not giving a detailed enough explanation. Notice I've written, if people hadn't written this and just went straight to that was very costly. You have to write, I always say in mechanics and probably in maths in general, when you write the first thing where you're inputting it into a formula needs to be written out carefully. And probably other things after that you might get away with, but your first line, if you skip that first line, it's going to be costly. So that was important, that you actually wrote that bit in there and not got straight to the answer, even though the question, oh no, it did say so that, so there's no excuse. I would do it anyway, but the question said so that, so you had to do that. Okay, so that's question 3. There were some that didn't realise. I mean, it was a bit of an unusual question, to be honest, but it probably may become standard over the years. But some people didn't make the connection between t being equal to 1.6 here in the first part of part C, and that actually being the point where there's minimum kinetic energy. Okay, question 4. Yeah, I think a lot of this is, first of all, the fact that it's extendable, I mean, was a little unusual, I suppose, but again, it probably won't become unusual. This was the first year of the series. Some people missing out forces, some people even missing out a reaction force. That would be absolutely deadly. Missing out a force in a mechanics exam is, well, you're going to forfeit virtually all the marks. You'd get the marks on the tension, but on the 7-mark question there, you're going to be missing out on most. But apart from that, it's just a case of applying the principles, resolving vertically, resolving using F equals ma towards the centre of the circle, and then taking it from there. Okay, so that's I say, relatively, I wouldn't say straightforward, but the issues are fairly clear. That is actually making sure that you put in all the forces in. Okay, question 5. Apparently almost all got the actual so that bit in this part of the question here. Sorry, the 45 has come out of the thing there. So, and then for the second part, the workings had to be, you had to show your working quite carefully on part B, because again it said so that. And then for the second part of the second part, the actual modelling bit, reading the examiner's report, they said the stronger candidates drew a graph, even though it didn't ask for a graph. The stronger candidates did draw graphs. It naturally occurred to them to draw graphs in this situation. As I say, a more detailed look at this question is provided in on this playlist following this video. Okay, and then part C is a relatively standard thing where you just look at a particular case. Right, now question 6 caused some problems, and they specifically mentioned it. If you roll back to the beginning of the tape, candidates not appreciating the importance of dealing with momentum in two dimensions, particularly on the second part. A lot of people apparently missed out the component that is unchanged by the impact, the string becoming taut, which is that many missed that out, and then some missed out the fact that the mass of that thing was 1, not m. The other thing that was mentioned because for the first part, you can work out the velocity is equal to that. There needed to be some explanation, which is why you'll notice in the tape I always worry about what the examiners are going to expect you to do. Mathematically, I feel it was particularly necessary to put m0 in. The examiner didn't require it, but you don't know that. The point is that it's a very good idea that you need to show, which is why it does no harm at all to say apply I equals change in momentum. And then that probably would have been enough in this question if it were clear that you're using the impulse on the particular particle. I probably might change that to on A, just to be even a little bit clearer now. Looking back at it, I would have put on A, because obviously you get a different, slightly more complicated equation if you do it on B, but you should get the same answer. Okay, a lot of people didn't seem to get part C, but in fact you didn't even need to do the first parts of the question to actually do part C. And question 7, the comments made on question 7 found it very difficult. I think it's all about doing good diagrams, working them through. I think a lot of the candidates who struggled would have been struggling for time at this point, which is why being efficient with your answers is important. The algebra gets a little bit complicated, but the actual principles of the thing are not that hard, but the algebra does get a little bit complicated and involved. Okay, so that's that was the final question 7. Good diagrams, making sure that you apply the equations, making sure it's clear what equations you're doing. So let's go generally back to the start again. General advice that the examiners give. Structured questions clearly, ensuring that they are easy to follow. So tell the people that you're doing F equals MA. Tell them that you're resolving vertically. It takes no time at all to do these things. Use a calculator to solve equations. That was particularly relevant in question 1. Think about it. It's probably you probably waste those that you didn't use their calculator to do it would have wasted a lot of time on question 1 when it wasn't required. Probably quite a few minutes. On a 90-minute paper, that could be quite costly. And again, communicate. It's almost connected. Communicating what the question says. And they've particularly mentioned question 6. A lot of people not dealing with the string and momentum question, and could use a range of techniques in unstructured questions, particularly the last question where you had to bring a lot of things together and simplify, kind of bring. And also, I'm thinking of the circular motion one, where you had to actually do quite a few different things, just structuring it properly. And then just don't fall into this. Those who hadn't learned key formally, didn't read the question carefully, misinterpreting key information like missing out the R, didn't check their solutions. I suspect some of this is time limited. It's easy to say that. I think a lot of people did run out of time, but you just need to be efficient. Couldn't show clear steps when asked to show that. Again, I think the word couldn't is perhaps, I'm sure the candidates did not appreciate the importance of showing the working when it said show that. So we needed to see that equation there. And we needed to see this here. Okay, let's leave it at that. And what follows now is a commentary on all the questions from 3 onwards of this paper. Bye.